And welcome everybody to the Daily Space Weather Show. I'm your host Dan, aka Smash-O-Mash, coming at you from the Smash News Network, least busted name in news, and we've got some new sunspots soon to rise over that eastern limb. We've also got an uptick in the likelihood of large solar flares as a result of especially the live and active sunspot groups that have been making their way toward the solar limb down there in your lower right of your screen. The southwestern limb is now the spot that is most likely for a large solar flare. So we do also have a high likelihood of solar flares in that northern group. It is quite magnetically complex. And let's zoom out one step further. These are 24-hour videos. And let's move on to our SDO continuum. So continuum's next, and there you go. Sunspots have declined since yesterday. A little bit of a downtick in sunspots, so if you're spooked of an inactive sun, now might be the time to get spooked. So if you're spooked of an active sun, now you can calm down. If you're spooked of an inactive sun, well, it's really not inactive. We still have over 100 sunspots on the Earth-facing portion, but there's the colorized magnetogram for today, January 24th, 2024. Next, don't forget to contribute to our Ask a Particle Physicist segment. If you'd like to contribute a question, well, you can do so at smashomash.com/forum. But more importantly, make sure you go subscribe to Eugene's channel, smashomash.com/forum to contribute. It is entirely free, and there's a second page now. If you'd like to see what the second page contains, well, go check it out. But make sure you subscribe to Eugene the Philosopher. Yes, Philosopher, Philostopher. Here are his hottest videos. Go watch every video on Eugene's channel. It's the Monotone from Minsk, the largest contributor to our channel. So go check it out. Eugene the Philosopher. Let's go over volcanoes next. Yeah, volcanoes. And interesting news at Grimvoten. There are some ice cauldrons that you should watch out for if you're traveling around Grimsvoten. Ice cauldrons are when there's a depression from magma and ice forms in it caused by glacial flows. And of course that can become very unstable, so don't get stuck in an ice cauldron. These are the other volcanoes that are currently erupting. The list includes Ibu and Merapi and Semeru and Merapi again because reasons. Also Tocono, Popocatépetl, Fuego, Revenador, Cotopaxi, Sabancaya. And that rounds out the list. Let's get to earthquakes. But first, a volcano map. So there are where those are located. And here are the past 90 days of earthquakes. Here are the past 24 hours of earthquakes from the USGS, and we'll call out the 5 and greater magnitudes. So it's been pretty calm here, but there are some suggestions that we could see some foreshocks of major activity, like this 5.3 in Indonesia. That could be the predecessor to a larger quake. What about this 5.1 in Tonga? Whoops. The list has just updated with an Asian earthquake. That 5.1 at Tonga was at 6:27 this morning. Chile had a 5.4. That was at 8:05. Universal Time Kermadec Islands had a 5.1. That was just north of New Zealand there, in between New Zealand and Tonga, near the Kermadec Trench. New Zealand itself had a 5.0. Looks like the northern island there. And then Papua New Guinea had a 5.0 as well. 5.1 at New Zealand, 5.0 at Papua New Guinea. Only about 20 minutes later. So quite a few 5 and greater magnitude quakes here for the past 24 hours. And the latest one was a China quake, a quake from China, okay? There's your China quake, a quake from China. All right, near the Kyrgyzstan border once again. Looks like an aftershock from that 7+ magnitude that happened the other day. Probably created with stolen U.S. intellectual capital. Okay? Now that I've gotten that out of my system, let's take a look at some more solar imagery. Here's the past 24 hours from SDO. It's 304 angstroms, the ionized helium wavelength. One of the absolute classics from Solar Dynamics Observatory. Or, if you're from the UK, the Solar Dynamics Observatory. Anyway, let's get on to some space weather stats here as I reappear. 10.7 centimeter radial flux is now at 170, I think is the 10.7. 170. That's the number I'm sticking with because I think that's right. There's the 1 year graph of it from Solon.info. The black line is the radial flux. The red line is the sunspot number. Right there. Red line, sunspot number. NOAA, 172 is the current radial flux. Actually, 172 solar flux units. That's the radial flux. And look at NOAA forecasting geomagnetic storms for days, as we said days ago. So, yeah, there you go. NOAA agreeing with our forecast. And interestingly, it looks like NASA disagrees, or maybe they're on vacation for space weather forecasting. I don't know, but it's kind of weird because NASA doesn't look like it's forecasting the same thing as NOAA at all. NOAA's forecasting like we are, and NASA is like, I don't see anything. Anyway, there's the NOAA Enlil spiral, which is a little bit more consistent with what we're expecting. Of course, the most recent CME impacts were complete duds. So it can happen, folks. You can have the magnetic fields decay that can be weak in the first place. You can have slow wind. You can have other things affecting the propagation of the CME. So far it's been quite calm for the past few days. No geomagnetic storms, period, from the latest CMEs. As far as NASA's forecast, look at their Enlil spiral. That is bupkis. There's nothing on there. So I don't know. It's NASA's wrong and NOAA's right, period. So, I mean, look, the channel does all the time. We forecast regularly. We forecast differently than other channels do. And, you know, it's I don't really compare notes. I do my own research and I look at the data myself and I come to my own conclusions based on what I'm seeing. So anyway, here are the past 4 hours of Earth's magnetic moment from space. And once again, it is geomagnetically calm, so not a lot to see here, folks. It's chilling. The magnetosphere is in geomagnetically calm conditions. So everybody chill, okay? Everybody chill. What the F are you doing if you're not chilling? Anyway, there's Earth's magnetic moment from the ground for the past 4 hours. And remember, folks, wear your brightest colors on the gloomiest days. You gotta have it, folks. Bright colors go with gloomy days. It helps to not get you run over also, so that's always good. KP index currently at 0.67. KP 0.67 is the geomagnetically calm condition currently experienced at Earth. And our real-time solar wind here showing weak solar wind as well. So slow and low at the ACE, similarly slow and low at the Discover. Only 450 kilometers per second with a 5.5 proton per cubic centimeter solar wind density. Magnetometers are pretty chill as well. No geomagnetic storms. Kind of surprisingly, actually. We were expecting a lot more fireworks than we got so far. But there are multiple new CMEs on the way, probably like 3 or 4. And there may be some new ones today. So we haven't even done today's forecast. And it's already lots of space weather on the way to Earth. Next, our top view ecliptic plane field plot. One of my favorites. And if you don't like it, then just fast forward ahead. I mean, that's the beauty of video on demand, unless you're viewing the premiere, in which case you can't do that. Earth is in a South Pole magnetic heliosphere sector, shown here in red. Here's our line of sight field plot depicting the solar B field in blue, polar fields in red and green, and the photosphere magnetism in grayscale. That is the past 4 days of a lot of information about what's going on in the closest star. And here is our line of sight coronal hole plot. Lots of South Pole oriented coronal holes, except the ones down to the south heliographic pole, which are now north because the solar polar field reversal process is well underway. And you can expect coronal holes to continue to be quite numerous and common throughout the next 20 months or so during solar cycle 25, because we've had a bit of a shortage. We've also had a bit of a plasma shortage. But that's what's going on. Next we'll show SDO. And some quality South Pole oriented coronal holes here are indeed rotating in. Both of those coronal holes, you see those dark features there with open magnetic field force lines, those are indeed both of South Pole magnetism. Next, we'll get the sunspots. And the sunspot number has now dipped below, below 130? Below 130, folks. So it's not time to panic yet about an inactive sun, because it's never time to panic about an inactive sun. That's just idiotic. It's also not anything less than imbecile to panic about an active sun. But there's the past 30 days of sunspot number. Current number is at about 123. 123 is the current sunspot number according to Rob. There's our synoptic map, where Rob is the Royal Observatory of Belgium. So there you go. There's our synoptic map, and we still do have quite a high likelihood of X-class solar flares. And again, my most likely place for a large solar flare is in that southwestern limb. So if we're going to see an X-class event, at the moment, I would say the most likely place remains down here. There is also some likelihood at 3559. So that's the solar flare watch. And let's take a look at SDO imagery. There we go. How you like them apples? That is the 171 angstroms 60-minute running difference along with the SDO continuum. And let's show just SDO continuum. So at least one new sunspot forming and then degrading over here in the east. Right down here, you'll see an umbra form and then evaporate. Or you could say get filled in, perhaps. Folks, sunspots are like depressions on the surface. And when I say the surface, I mean the photosphere, the layer in between, the layer below the chromosphere and below the solar corona. The photosphere is what you're looking at here. The surface of the sun where sunspots occur. Anyway, it's time to move to solar energetic particles and solar flares. So, first, solar energetic particles. And where am I? Oh, I must be in the constellation Cygnus. All right. There we go. There is the ghost proton flux, and we don't see any relativistic particles. The X-ray flux here is pretty choppy. Background flux is at about a C1.5. And we have had some M-class intensification, so let's take a look at those from the SDO. There you go. There's SDO 131 angstroms along with 94 angstroms 60-minute running difference. And as you can see, consistent with my forecast, the most active region is indeed down there in the southwest. Here we've subtracted the 94 angstrom 60-minute running difference. Now that's just 131 by itself. So tell your friends, tell your foes, so that all of them know that there is a solar flare watch in the southwestern limb of the closest star. There's 94 angstroms by itself, and just for sake of completeness, we will add the 131 angstroms running difference of 60 minutes. Now, we will have a rising likelihood of large solar flares at the southeast as well, especially, but also the northeast. So, sunspots have a tendency to produce the largest flare when they are near the limb of the closest star, and so they make a big entrance and a big exit, typically. Next, we'll take a look at a star chart here. Let's calm down and look at some more chill stuff. That's what's going on overhead Lehigh Valley, Pennsylvania right now. We got a nearly full moon up there at the moment. Next, your solar system forecast. This is from theplanetstoday.com. By the way, this is where things are today. That's where things will be in 1 week, and we're almost in February of 2024. How did time go so fast? How have we gotten here? Next, our astronomy picture of the day, and this is from apod.nasa.gov. If you want to check it out yourself, another blue marble image here from Artemis 1, I believe is when that was, in late in 2022. So a picture from beyond the moon. Yes, stand by for a kicking of bad theories about how planets are shaped. Next, CMEs are next, and they're pretty exciting, right? So let's do it. Here are CMEs from today at George Mason University. That's 81 frames. And we do have additional events. And yes, there are additional earthly directed components. So that's pretty sweet as we extend the geomagnetic storm watch for yet another day. So more showing up on the 27th, folks, and into the 28th. Yes, it's great. So here's Alaska C2NC3. And there are 2 events today that look like they have earthly directed components. Maybe even 3, but at least 2. Let's take a look at our custom coronagraphs. There is a 24-hour video featuring SDO 304 angstroms, the C2, which is in red, and the LASCO C3, which is in blue. And yeah, multiple additional Earth component containing CMEs. Yeah, good times for space weather. So those both came from over here in this region, both the northwest and the southwest. Looks like 2 more CMEs likely to have earthly directed components. I'm excited. What about you? Let us know in the comments what you think. Don't mind us. We're just bringing you the world's most comprehensive daily space weather show and most detailed solar imagery you'll find in the known universe. What's that? That's not close enough? There we go. How's that? That's 304 angstroms along with 193 angstrom 60-minute running difference. Fantastic at showing great depth to the solar corona, solar filaments, the extended corona, and active regions. Here's the full equatorial zoom. And so 1 event before midday, 1 event after midday. I think the first was around 7 o'clock. I think there are flares associated with them. I'm not going to dwell on it because guess what? I don't really need to worry about it too much because guess what? Still not going to destroy civilization, folks. So let's move on to filaments. There is Cerro Tololo's ground-based solar observatory depicting hydrogen alpha. This wavelength is 6,562.8 angstroms. And let's show the scale, the color view, there we go. Once again, Cerro Tololo, Chile's hydrogen alpha telescope. Some massive filaments here once again. And this one ought to get a name since it's right in the Earth-facing strike zone. That might be a good filament to name. And if you want to name filaments, make sure you join us over at Twitter. Yeah, twitter.com/smashomash. Or perhaps you prefer x.com/smashomash. I don't know. And before we get the bonus features, here are the past few hours. A CME popping off there, and you can see some instability here and some instability up here. Looks like a CME there as well. Very nice. Very nice. That is some pretty sweet activity there. And good times, good times. Let's get the bonus features, starting with satellite charging hazards. And by the way, I almost dropped this segment from the video, and then I realized that since it can cause communications breakdowns, this might actually show some erroneous data when we get to our weather segment, so I decided to keep it. Satellite charging hazards. We ain't got none. It's smooth sailing. Next, it goes electron flux, and that's the past 3 days. Pretty low here as the electron shortage continues. There's the 1-year graph of it, and you can see that lengthy electron shortage here. And we were expecting some more electrons. So a bit of an electron shortage, and it looks like NOAA is expecting the electron shortage to continue, folks. Now, keep in mind that readings do become erroneous when we have geomagnetic storms because the ionosphere puffs up, and the radiographic measurements from the GOES 16 and GOES 18 are measuring the F-flare at the ionosphere for the electron flux, so it becomes an erroneous reading. But anyway, without getting too into the weeds on that, there you go. The forecast model from NOAA, represented by the green boxes. Next, we'll show the layer where it's measured. How about the F-flare? What do you think? It's the bridge between Earth and space at about 300 kilometers of altitude. There is the F-flare in its raw vibrational frequency, and it is quite normal here, so not very exciting, as space weather has been weak. Hey, what can I say? The impacts have not been what we've expected. We thought we'd see some geomagnetic storms. So we're still expecting some geomagnetic storms because, hey, when something weird happens, you don't change your forecast. You go, well, that was weird, and then you move on. And you don't get gaslit about how reality actually played out. Next, our anomalygram. That's anomaly in megahertz from a 30-day median. And yeah, like I said, plenty of red, plenty of blue on there. It's quite run-of-the-mill. It's unremarkable. We'll also show the Global Ionospheric Nowcast, or WAM, the whole atmosphere model. There it is. GPS users pay attention to the left panes. High-frequency radio users pay attention to the right panes. You're both pains in the, you know what, in the tuchus. You're pains in the tuchus. Now, don't take this as a personal affront. If you are mad about it, make sure you leave a comment, though, because we highly encourage rage comments. If anything in this video makes you enraged, make sure you tell us in full detail in the comments section. As we read all comments, we just don't respond to them all, especially if you're nuts. Anyway, there's the sun, the latest high-res images, the colorized magnetogram and continuum. And let's move on to some Earth weather. Yeah, Earth weather, and it's pretty. There's some pretty bulky weather going on right now, so let's get to it. First of all, in the Northern Hemisphere, you've got a bunch of lows, and those are affecting things. You've also got some very high-pressure zones, like little parts of Greenland, where it's very, very cold. This high-pressure dome right here, that's really it's an upside-down dome, because it's more like a depression, but that's high pressure right there, and it's like 50 below zero, or I think it's pushing 60 below zero. So those are the world's mean sea level pressures and surface winds. I'll show you the southern hemisphere as well. There you go. There's the South Polar region. Always a delight. You know, a great place to go sailing for fun is the Southern Ocean. Just kidding, folks. It's a treacherous disaster. Anyway, let's get to our regularly scheduled meteorology. There are the surface winds of the east, jet streams of the east, jet streams of the central world, surface winds of Europe, Africa, and the Middle East, surface winds of the Americas, and the jet streams. Next, clouds and fog for the Americas, depicted by shortwave radiation. Space-based systems at 3.9 micrometers, infrared. We'll also show a close-up of these heavy storms that are striking the Gulf states as forecasted. As we bring the weather from the sun all the way down to the lower 48. Your space and Earth weather together here at the Smash News Network, least busted name in news. And just a quick reminder, never try to sneak up on a dragon, because a dragon is 100% immune to surprise in its own lair. So there's one to grow on. If you're going dragon slaying, don't try it in its own lair. You'll fail. You'll fail, and fail hard. Here comes some rain forecasts. And check it out. We've got this huge band of very heavy rain, and it's very likely to be that heavy. So there are the next 12 hours, the next 24 hours, and the next 3 days on the Euro forecast model. That's 5 inches of rain in large swaths of the U.S. There's the GFS model also showing over 4 inches of rain. So take heed as rain shows up promptly. Here's our weather.gov map, and lots of flooding, lots of moisture, and lots of, well, that stuff that you see there. I scrolled down to show you the key. Those are too many counties to cover. If your county's lit, click your county at weather.gov, and let's move on to our forecasts. Starting out with the Tropical Tidbits GFS 72-hour. There you go. 72-hour GFS pressure and precipitation from Tropical Tidbits. Pay attention to the pink, because freezing rain is suboptimal for driving and doing practically anything. Next, total accumulated precipitation forecast in inches. And as you can see, heavy rains are coming. Take heed, as water can show up quickly. Tropical Tidbits forecast for the accumulated positive snow depth change based on the same model, the GFS 72-hour model. Snow depth totals are listed here in inches. Next, the temperature anomaly forecast in degrees Celsius. Same model, GFS 72-hour, and a bunch of warm temperatures coming to the east, especially the Mississippi Valley and points east of there. In fact, most of the country will be anomalously warm. It's an early thaw for all that snow. Once again, thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, and I'm not done with this broadcast yet, but I just figured I'd act like I was. There's lightning, and we've had some heavy lightning there across, especially Mississippi, Louisiana, quite a bit in Texas as well. Let's check out a real-time lightning map from lightningmaps.org. Next time you hear thunder, scope it out. Lightningmaps.org. Convince the natives that you're Zeus or Thor or something. Galveston. Sweeney, Texas. Also Bay City and Freeport. Some significant thunderstorm activity there and some heavy storms. And here is the Doppler radar. That's radar.weather.gov, by the way, if you want to use that radar. I have the shortcut on my phone, so I like radar.weather.gov. It's fine. I mean, it's stitched together Doppler radar systems. You got to have it. Let's briefly zoom out and show the full 50-state view. Quite a bit of precip here, mainly in the eastern part of the U.S. Anyway, there's the lower 48 view. Here is the clouds and fog view for that. Here is the water vapor map. You can see huge pressure gradients there stretching across the southeastern U.S. Here's the recap. Ground-based Doppler radar systems which show vertical motion in the air column. If they're tuned right, they'll show you precipitation. Space-based systems show infrared radiation at 3.9 micrometers. It'll show you clouds and fog even at nighttime. Space-based systems that show 6.61 micrometer infrared radiation shows you water vapor, as in the dry air, the moist air, and all the rest. And here's me tuning out. It's time to get this thing onto your screen, so thanks for tuning in to the Smash News Network, Least Busted Name in News. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off, and may that solar wind be at your back.